Good morning, and thank you for President of the Arctic Circle and past President of the Iceland for inviting us to this forum and to discuss and share something about what is the connection between India and the Arctic. So I will be just briefly touching about what is the science drivers for us to work on Arctic and India. That I will talking about the science aspects of it, and my colleague Dr. Vijay Kumar will be talking about what are the infrastructure or what is the science we are doing in all three poles, especially Himalaya, Arctic, and Antarctic. So I'll be touching on only why we need why India in the Arctic. So that's what I will touch upon. Of course, the answer is, I have already mentioned that is a big bold letter, it is a monsoon. Why it is the monsoon? Actually, first and foremost is the teleconnection between the Arctic and our monsoon in different time scale, both intraseasonal, interannual, and decadal time scale. We have modulated the Arctic and monsoon. And this type of short-term variability, it is called, we call as an atmospheric bridge, and the long-term ocean tunnel, it is in terms of sea level variations and other things, it is taking place in the long-term area, long-term effect. So also we want to see the rhythm of past history between the Arctic ice core and Antarctic ice core and Himalayan ice core. What was the past history? And so that we try to construct or try to understand the history, and then we go for prediction. Of course, the strongest signals, if you see the climate change, the stronger in Arctic is the melting ice, and in the Indian Ocean, it is the warmest trend. That means in the tropical belt, you can see that the warmest ocean is the Indian Oceans. So that is the important things. So globally, the climate change indicators, there are three main global change indicators. It is a surface temperature warming, and decrease in sea ice extent, and the sea level rise. So all these three factors, of course, there are very major three factors, it is influencing the monsoon. So I will tell about why it is influencing, how it is influencing. Before going to that, Indian Ocean is warming faster than other oceans in terms of both the sea level component of thermospheric as well as the sea surface temperature. So whatever the heat gained in other oceans, it has been transported to Indian Ocean, and Indian Ocean, as you know, that it is unique. The northern side is blocked by Himalaya and Indian continent. So the heat trapped in the tropical Indian Ocean cannot pass to polar regions. So it has been almost trapped in the Indian Oceans. So the warming become increasingly noticed in the Indian Ocean. And of course, the sea level also very highest in this recent decade. It is almost double the global mean in the Indian Ocean sea level. So once it is warm, the Indian Ocean warm, it is almost very well known that it is a reduced rainfall over India. So if the warming trend in the Western Arabian Sea or Western Indian Ocean, it is noticed, then you can see that the decline in monsoon rainfall. So this is the Indian Ocean scenario. The one thing is the sea level is higher, especially the steric component, and SST is higher in the Indian Ocean. These two causes the monsoon decrease. So what is that in Arctic? So when we come back to Arctic, there are two climate issues. One is Arctic amplification and sea ice decline. There are two important science drivers which influence the global climate. And these two drivers, how it is affecting the Indian Oceans. So before coming to that Arctic amplification, you all know that the temperature rising much faster in the polar regions, especially in the Arctic. And this increase in temperature causes sea level reduction. And we worked out what is the relation exists between the monsoon and the sea level, sea ice extent. So in order to do that, one of the regional specific, we looked at it. One of the region is the Kara and Parent Sea. That is a very good correlation between the Indian monsoon and also the Arctic, sea ice extent. So if we just look at the how the variation is happening, it is if the monsoon increases or the sea ice what is called extent decreases, and the monsoon, it is more or less some correlation. Though it is 0.34, it looks maybe small, But if we know that El Nino also, it is about 0.35 or so in the monsoon relation. So that is very big signal for us when compared to other signals. If you see that the interannual variation of sea ice extent and Indian summer monsoon rainfall, you can see one-to-one variations. And the next one is if we come back to Arctic oscillations, there are this variation in Arctic oscillations. You can see that there is a change in meridional gradients of winds, and because of that, you can see the ITCZ migrations. So this ITCZ migration which causes a lot of intraseasonal variations in the Indian monsoon, and that creates a lot of extreme events. So this meandering of polar jet stream, it causes mainly the extreme events in India. So if you just compare between Arctic oscillations and the monsoon, it is also more or less some relation exists, but year to year it is increasing these relations. So these extreme events, whatever the extreme events are happening in the Indian monsoon, it is very, what we have noticed is in the recent time period, the extreme events are increasing, whereas the light rains, it is decreasing. So though the annual mean of Indian summer monsoon rainfall is almost same, in the long term it is not much difference, but the extreme rainfall, extreme events, it increased over the 50 years. And this extreme rainfall causes the reduction in, it is causing the floods, and also in some of the area there is no rain, and there it is a drought. There are two problems created because of these two extremes. So these extreme events, it is not only problem for us, and it is also problem to the polar latitude, because these extreme events causes the latent heat release in the atmosphere, and that latent heat release in the atmosphere, migrated towards the polar regions, and then you can get in the polar region, there are more ice melts. So these are the some of the events. Whenever you have a strong extreme events happening in the Northwest India and Pakistan areas, and you will get a more what is called sea ice melting. It happens in the polar regions. So essentially what I want to convey is in Arctic amplification or sea ice extents causing the problem in the Indian monsoon region, especially in the intraseasonal time scales or in the annual time scales, we have a problem, and that changes, then we have extreme weather events. That extreme events in turn modulates the sea ice extent in the Arctic Ocean. So in summary, what I want to say that there is a connection between poles to tropic. So observational analysis suggests linkage between Arctic and Indian monsoon through sea ice and Arctic oscillations, whereas tropics to poles, that is the reverse one, a close link between monsoon heating and sea ice melting, and this causes the problem to the poles. So we need to understand more and more about this, and that's why we thought to make more observations, and both in situ as well as satellite observation, including some of the modeling effort, so that we can try to understand and we can predict better the monsoon. So the India is basically, if you tell about monsoon, that's everything. So in country's economy, all these things are dependent on the monsoon. That's why if anything is happening anywhere in the world, and when it is affects to monsoon, then we always worry about it. So that's why we are trying to look at what is the teleconnection between that, what is the rhythm exists, and how it is moved over the past few years or hundreds of years, and then whether we can try to predict, because now it is already, we have clearly noticed that the monsoon extremes are going on, the extreme rainfall, it is going on increasing, and this is worrisome. Not only that, and we have, Indian Ocean is warming faster, and Bay of Bengal, there is a Himalayan river, a lot of river has been put into fresh water. So the fresh warm water creates a lot of stratification, and that creates a lot of more and more extreme events. So this is some of the areas of collaboration we would like to do it in a country. So basically we want to have observational components as well as the modeling component. We would like to work on these aspects. Thank you very much.